So what is a super data type? So super data type is something which stores semi-structured or document values like JSON. Essentially, super data type is meant for JSON data only. So what you can have is that in a single table, either all the columns are of super data type or other columns are normal data types like integer, character, etc. And one of the columns or maybe two or one or more columns have super data type. And it can store up to 16 megabytes of data in a single column. That's how big it can be. The way you query super data is a little different. It is not conventional SQL because it is stored in JSON. So the way you actually query the data is different. Now, one more thing is when I say query, I only mean select statement. You cannot update a single element in a super data type. Let me tell you what that means. So this is, let's say, a table wherein I have employee ID, employee name, date of joining, and technology. So employee ID, let's say the data type is integer, employee name is data type is varchar, date of joining is date, and technology has a super data type, and the data is like this. So as it is JSON, we have key and value. So the first key is cloud, whose value is AWS. The second key is code, whose value is an array. And it has two elements. The 0th element is Python and the first element is Java. So this is an array. And then we have experience, which is an integer, and the value is 10. Now, how do you query? So you run a select statement like employee ID, but if you want to fetch individual attributes or individual keys of the super data type, you'll have to mention the root column. In this case, it is technology dot the attribute that you want to fetch. So let's say I want to fetch the first attribute. So it will be technology, which is the root column name, and then the attribute name, which is cloud. Now, as the second one is an array, I need to get the elements of the array. So to do that, again, I'll have to mention the root column name, which is technology, the attribute, which is code, and which element I want to find or which element I want to fetch. So in this case, I want to fetch the 0th element or basically the first element. That's why I have written 0 in square brackets, it is 0. Then in the third one, I want to fetch the experience attribute of the technology column. So it is technology dot experience from table where value equal to employee ID, and it will give an output like this. Of course, the employee ID, which is 123, AWS, Python, and 10. Or else you can select just the column technology and it will output you all the attributes of that super data type in JSON format. So let's have a hands-on on super data type. But before going into the hands-on, I want to tell a little bit about the source dataset that we'll be using to load the table. And this is the source data type, olist underscore orders underscore dataset. I have 8 datasets from 1 to 8, and this is the JSON. So if you see, each one starts with a curly braces and then ends with curly braces also. This is one record, right? So from here, if I show you, this is one record. We have order date, seller ID, etc. Everything is in JSON, and then customer address is an individual JSON document, and then it ends with curly braces also. The second record starts with a new line, so it is not comma, it is not anything. So use these type of files to load in your Redshift table if you have a super data type. If let's say you have a JSON file wherein all the records are mentioned in an array, then you will get error. What I mean by that is, some JSON files are like this. You have all the records in a single array. So if you see, it is starting with an array and it is ending with an array. So square brackets, and we have 3 records. So this is the first record, or this is the first JSON document. Then you have the second JSON document and the third JSON document. And these are separated by commas. So this is the first record, and the second record is separated from the first record by comma, and the third record is separated again by comma, and this is the last record, by the way, and the array ends. In some cases, you will find JSON files like this, wherein all the records would be presented as elements in a single array. So you should not use these type of JSON files, because if you want to load using these type of JSON files, Redshift will give you error. You cannot load this type of data in super data type. So what will happen, Redshift would think that this is a single record, and if it is pretty big, then it will give you error that it is beyond 16 MB. So do not use these type of files. Always use these type of files wherein the records are like this. So this is the first record, and this is the second record, which is basically separated by a new line or enter, and this is the third record. Now each one of them is a JSON document, and each row or each line is one record, and the next line is basically a new line or an enter, and there's no array. The records are not contained in a single array. This is how the source file should be. The source JSON file should be if you're trying to load it into super data type. Now, how do you load a super data type? So this is how you do that. So I have loaded till 7, and this is the 8th file. Again, the command is there in the command sheet. I'm loading it into retail ordered item JSON. I'll cover the copy command later on anyway from S3 file. This is a JSON file. Everything remains the same, only the format is different. So here the format is as JSON auto. Now what will happen is, because my file is as such that I have order ID, customer ID, seller ID, and these individual attributes would be considered as columns in Redshift table. Of course, you'll have to create the Redshift table beforehand, like order ID with whatever data type you like, customer ID with whatever data type you like, so on and so forth. But the last one, customer address, is a super data type because this is a JSON document. So while creating the table, I created the table as such. So let me show you the definition of the table. As you can see, this is the table: order ID, customer ID, seller ID, order date, price, payment method, and customer address. So all of them, this is varchar 100, integer, date, numeric, varchar 100. This is super data type. So this is how I had created the table, and the primary key is order ID. The table creation is similar to as that of CSV file. The only difference here is that the customer address is of super data type. Why? Because my file is as such that the customer address, the value of customer address is contained in a JSON structured document. So that's why I have created that customer address data type as super. Now for the other ones, I have order ID, I have customer ID, I have seller ID, so on and so forth. So when I mention format as JSON auto, the Redshift copy command will try to match these attributes with the column names. Now let's say we have an additional column name for which the attribute is, or the key, the JSON key is not there in the file. So in that case, the copy command will fail. Anyway, I have loaded all the files except for this particular file, which is JSON 8. Now let me execute this. So execution is done. So 1000 records have been loaded successfully. Now let's take a look at the queries. Okay, do a select star from order items JSON. So this is how it is. I have order ID, customer ID, seller ID, order date, so on and so forth, and then we have customer address. So if you see, this is the customer address. Now I have line 1, line 2, second floor, sorry, line 2, zip code, city, state, country, phone. Inside of phone I have mobile, home, and office. So if I copy this, so let me open jsonlint.com and I paste that and validate JSON. So this is how my customer address is. So this is a document, this is a JSON document. I have line 1, line 2, zip code, city, state, country as keys along with phone. All of them are actually strings. Then phone is another key or an attribute which contains an embedded JSON as a value. Now inside of this I have multiple other attributes like mobile, home, office, emergency, etc. Right, so let us query this line 1, zip code, city, state, country, and I'll also try to get the mobile phone from this particular. So let me just keep this handy. I'll query it using query editor. Okay, first is that let's do a select star from order. Has to be retail schema, retail dot order underscore items underscore JSON, where customer underscore ID equal to some value. So if I run this, it should show me the record, right, that I have seen. Okay, so order ID, etc., etc., everything is fine. Then this is the customer address. Now if I go back, this is how it is. So let me get only customer address. So select customer underscore add address. So where customer ID equal to some value. So it should return me the entire JSON data. Right. So if I increase it, see, I have the JSON data. Of course, it is not easy to read. Now let's say I want to find the customer ID, and then from customer address I want the line 1. So this is how I would select. So if I run this, I should be able to see customer ID and only line number 1, or basically the line 1, which shows 6th floor. Now what will I do? I will try to fetch customer address dot, let's say, zip code. Now why dot? Because again the root followed by the attribute zip code, right? So if I execute this, I should be able to see the zip code also. Now I have an embedded JSON, so let me try to get the mobile phone number of this particular customer. So it will be customer address dot phone dot, why dot again? Because again this is an embedded document, this is not an array, and I want the mobile. So dot mobile, and it should give me all the records, right? So as you can see, you have customer ID, line 1, zip code, mobile. So this is how we query a super data type. Now one thing is that what if you want to update line 1? Can you do that? As I already told you that you can't, but let us try that. So this is the update statement: update order items JSON, set customer address dot line 1 equal to 8th floor, where customer ID equal to some value. So if I run this, I should get some errors saying that, okay, so it says partial tuple update on super column is not allowed. Now if I have to update, I'll have to update the entire column. I cannot update a partial tuple of super data type. So what I have done here is I have mentioned customer address, and I have to use this particular function JSON parse, and I'll tell you that later on. But now let's say if I do not use JSON parse and I just put an array, the string here, and inside of the string I use this JSON document, it will get executed successfully. Now if I select this particular row, you see this, it is basically a string, it is not a super data type. Now if I try to find out, or if I try to fetch customer address dot line 1, it should not give me any value because it's a string and it is giving me null. You cannot update or insert using single quotes. Instead of that, you'll have to use this function JSON parse, and after and inside of JSON parse, you'll have to mention this string. And now if I run this statement, I should be able to update it. And let me see customer address first. So my customer address is a JSON document. It's a super data type document. And let me try to find out customer address dot line 1 and customer address dot text followed by the first element. Now it should give me customer ID, customer address line 1, and AWS. Now execute this. So if you see the customer ID, the address, and then the tech is AWS. So this is how you update or insert a super data type. You need to use JSON parse, and inside of JSON parse function, you'll have to put the entire JSON document inside of single quotes. Insert also it would be the same, and in update also it is the same. You cannot update individual items or individual keys or attributes inside of a JSON document in super data type. You'll have to update the entire column. So that's all about super data type.